Hello everyone. What is the topic today is deep neural networks. So here, what is the title is bias and variance. What is the purpose of this bias and variance? So where we are using this bias and variance, and last we have seen about the neural networks, right? From that, how it is using the bias and variance. So these are the topics we are going to cover in this slide. Myself, Dr. J. Sindal Kumar, Assistant Professor, Department of Computer Science and Engineering, KIT Kalinga Karnataka Institute of Technology, Coimbatore. So let us start our points. That is an bias and variance. The topic is. So what is bias? The bias and is an refers to an error occurs by the over simplifying a model, while a variance is refers to the error from making the model too sensitive to the training data. So here you can see that high bias and low variance. So my target is here, but my accuracies, all the accuracies is predicted here. Okay, that's one we are calling as high bias and low variance. Here you can see that low bias and high variance. My target is here, but you can see that low bias is uh, splitting all the sides, but high variance it is accurate nearby that it is my target is achieving. So this is we are calling as high bias and variance. Bias and variance are two fundamental concepts that helps explain a model predictions error in machine learning. So we are using this bias and variations in machine learning concepts, which is used in the weight and bias. Like we will be calculating weight and bias here, while weight will be modified with the help of an mean square errors, and with the help of the biases will be modified. So here we will be seeing about the variance about refers to the errors from making the model too sensitive to the training data. So let us go in depth of this topic bias and variance. Here you can see some like a graphical structure. So we'll see that in graphical in depth in later. So keep in mind we are going to calculate the total errors and with the help of bias, variance, and we have this optimal model complexities, and we have the model complexities here. So these positions will be calculated with the help of the bias square and variances. So let us go into in depth of this topic. So first we had to start with bias. Bias is an errors introduced by the approximating real world problems with a simplified model. It measures how much that model predictions deviates from the true values due to the assumption in the algorithm. So what is this bias is, suppose the value of the prediction is x values is x and y my input. So if my input is 1, my actual output is 3. Instead of predicting the 3, I am getting as 5 or 2. So what is my difference between these two values? It will be an 1, right? So this one we are calling as error. So this error will solve with the help of the bias and the variance. So here we are going for the high bias. High bias occurs when the model is too simplistic, that a linear model for the nonlinear data sets leads to the semantic errors. The symptoms include the poor performance on both training and testing. So while doing for the training and testings, the high bias will be the in the form of if it is in the form of an too simplicity, this high bias will be occur. The source understand the parameters model incorrect assumptions, that is assuming the linearity in the quadratic relationship. So what is the impact of this high bias is high bias causes the model to miss the relevant relationships between the features and target, resulting in the underfitting. So if it is in the form of this kind of an errors, it will be considered as an underfitting. So we'll see that underfitting with the help of some graphical structure in later. So keep in mind, if you're going for this bias work, then we'll be seeing about the underfitting, right? Bias is an inheritance in the model structures and independent of the training data variability. Next, you can see that underfitting. This is my original data, but my model is predicting in this directions. Then we are calling as underfitting. Okay, so being an high in the biasing gives a large errors in the training. So these are the training data sets. While training the data sets, my data sets is going like this. So instead of going this narrow like this, it will be going in a straight line. Then what will happen? If a new data sets are in any kind of predictions, you will not predict it exactly, because you will miss some the data what is available here, as well as the training and testing data sets. We recommend that, yeah, that algorithm should be always main low bias to the avoid the problem of underfitting. So to avoid the problem of underfittings, we had to low bias the system. Okay. By high bias and the data predictions is in the straight line. The format thus not a fitting accurate in the data sets. Such fittings is known as an underfitting. So this is we are calling as underfitting. In the such problems, the hypothesis look like this. So it will be look this is in this format. Next, we are going to see about the bias. Bias is the errors that occurs when the model is too simple to capture the true patterns in the data. High bias. So, if it is in high bias, the model is oversimplifying, miss patterns, and underfit the data. Low bias means the model captures the pattern well, and it is closer to the true values. Example: in a neural networks, the too few layers or the neurons fails to capture the complex patterns, they're producing the consistency inaccurate output. This one we are calling as underfitting. So it will be calculated with the help of the mean square errors like this. Okay. Where f of f cap of x is predicted the values by the model. So actually we are talking about the my actual is output is 3, but my prediction is 2. What is the loss here? We will get as 1. So this loss will be solved with the help of this bias and the true values. Okay, f of x is then true values. What is the expected predictions over the different training data sets? It is an e values, right? So with the help of this calculation, we can calculate the bias IRS, right? How to reduce the bias? Some methods to lower bias is in models are use more complex models. Use models capable of capturing the nonlinear relationship, such as neural networks or NSML methods. Add relevant features, including the additions informative features in the training datasets to give the model for capturing the underlying patterns. Adjust the regulation. So here we have the regulation structure strength, that is L1 and L2. We have to strengthen that with the help of this regulations. Reduce the regulation to allow the model from more flexibles in the training in the fitting the data sets. So this is a way to reduce the bias. Next, what is variance here? Variances arise when the model becomes too sensitive to train a data and it captures the noises in the data too. It fails to give the predictions on unseen new data sets. High variances, the model is too sensitive to small changes and may overfit. So here we are going to for a variance. If it is variance, it will be considered in the form of an overfitting. Okay, like a lower variance, the model is more stable but might miss some patterns. So model is more stable but might some miss patterns here, right? Variance, okay. Variances quantifies the model sensitive to fluctuations in the training data. It measures how much the predictions for a given points vary the difference between the training and testing set. Here, high variances happens when the model is too complex. So here it will be more too complex, capturing the noise rather than the underlying the patterns. It performs well on the training datasets, but poorly in the unseen datasets. Over parameterized models, inefficient regulations, or small training datasets. Impact: high variances leads to an overfitting. So here if overfitting is simply working on where the models memorize the training examples instead of learning the generalization rules. So variances reflect the model flexibility and how it changes with the different samples from the same data and distributions. So this one we are calling as variance. Next, the variability of the model predictions for a given points, which tell us the spread of our data, is called variance of the model. The model with a high variances has more very complex fit to the training data. Such this is not capable of fitting the accurate. So what is this happen here is we can see that my data is like this. Okay, my data is available like this. My model is predicting in this where my data is available, maybe it will be predicted like this also. So if it is predicting like this, it is an we are calling as an overfitting. When a model is high on variance and it is said to be an overfit of the data. Overfitting is fitting the training set accurately via complex curves and high order this is hypothesis, but it is not in solutions as an error with an unseen data is high. The such problems hypothesis looked exist, so it will be looked in this format. Okay, so you can see the formulas as well as the bias where what we have seen here. So the variance arises when the model becomes too sensitive to train the data and it's captured the noise in the data too. It fails to give the predictions or unseen new data sets. So high variance, if it is in high variance, the model is too sensitive to small change and may overfit. Low variance, the model is more stable but might miss some patterns. So here we will be using a deep decision trees that memorize the data training data sets perfectly, but performs the poorly on the new data source, shows the high variance. This known as we are calling as overfitting. Okay. So how to reduce the variance? The some methods to reduce the variance with the help of and simplify the models, increase the training data sets, apply the regulation. So here also we'll be using a L1 and a L2 regulation to constrain the model complexity and prevent the overfitting. So use the NSML method. So we'll be using a fun NSML method for the variances. The implement the techniques like in backing or random forest to combine the multiple models and the balance the variances and trade-off. So we are going to see about this variations and bias and variations trade-off. Right? What is this bias variances trade-off? If an algorithm is too simple, like an hypothesis with the help of an linear equations, then it may be an high bias on the low variances conditions, and thus it is an error prone. If the algorithms too fit complex, that is, then it is an maybe an high variances, low bias. It is an later conditions. The new entries will not be performed well. This something called as both the conditions known as trade-off or bias variance trade-off. This trade-off is in complexity is the why there is an trade-off between the bias and variance in an algorithms cannot be more complex and less complex at the same time. So here we are going to see about the trade-off which is used for the like an algorithm is too simple, algorithm is too complex, and when we tell with a simple like high bias and low variances. When it will be too complex, here you can see the high variance and low bias. So if it is happen like this, then we have to solve with the help of the techniques like in trade-off and some of the techniques which can be solve the problems easier. So, what is this purpose of this means? You can see the variances trade-off. They try to optimize the values of the total errors. So, with the help of the total errors for the model using the bias variances trade-off. Here, total errors is equal to bias square plus variances per irreducible errors. So, the best fit will be the given by the hypothesis on the trade of the point. Here you can see that values of bias and errors, which is a common model complexity and errors. So with the help of this graphical methods, that data and that my model is had to go in this form in the structures for the prediction of new data sets for prediction of the new data sets. So exactly we have to predict if we want to accurately predict my new data sets, we have to calculate this formula to calculate the total errors. Then we can identify we can solve the errors with the help of the mean square errors, cross entropy errors. I mean, we have lot of error corrections methods, right? So, bias variance is trade-off. The total prediction errors depends on the trade-offs between the bias and variance. So, if the model is underfitting, the bias is high and low. So, what is happening here is the result is true training and test performance is too low. So, if it is an overfittings, so what will happen in bias is low and high in variances. The poor test and performance is poor. Then if it is an optimal, if it is an exactly that what is happened in this diagram, so that is an optimal. So it is an moderate and this is an moderate and base generalization. Why should be we have to get in the moderate means that is if you're going for a new data sets, I have to predict my new data sets is what kind of an data sets. So then with the help of this moderate I can easily predict it. I can easily predict my new datasets where the main what is the values I can give for the new datasets. The idea models achieves a balance of models not being too simple that is in high bias and not too complex that is in high variances. Okay, so what is the application of a bias and variations and trade-off is some of the applications bias and variations are model selections, hyperparameters tuning, model evaluations, error analysis, and NSML learning. So these are the applications where the bias variances trade-off is used. What is the advantages if you are using as bias and variances? Some of the advantages are improve the model accuracies, support the efficient trainings, enhance the interpretability, guides the model's complexities. So we can create a model in an accurate manner with the help of the bias and variances trade-off. So here, what will happen if you are using this bias and to solve the bias and variances, improve the model accuracies, support the efficient trainings, enhance the interpretability, and guides the model complexity. So this will happen. So what is the limitations? Some of the limitations of the bias and variances are difficult to quantify the precisely, highly data dependent, unpredictable in data learnings and trade-off challenges. So this will happen as in limitations. So next we are going to see about that in what will happen in the machine learning concepts. If you are using as bias and silence, what will happen here is if it is a high bias and low variance models, the model will be the high bias are too simple and hence is underfit. They work properly on the both training and testing. So here we can see what we are seeing in the graphical method. Okay, so here you can see the machine learning of graphical structures. So this is the like an regression illustrations under fitting, high training errors closest to the test error, high bias. Here you can see that my model is here, but data is here, so it is not train all the data. Here, what is happening is this is in between the data, so it will be it will be all the it will be predict the new data easily when the data is when the model is like this. Here you can see my models cover all the data sets, so it is an overfitting and it is an underfitting here. Classification illustrations. Here you can see the classifications. It is not covered all the data. Here it is covered all the data with the help of this my model. Here accurately covered my data, so it will be in overfitting in the classification regression. While of deep learning methods, here you can see the errors and validations. So how it is, the epochs is different. You can see the values as different here, and then errors. So here, what is this exactly? What is this happened is we cover here validations and training here, and you can see the gap between this. So it is an overfitting of data. Right? The possible remedies. So complexity of the model, add more features, train the longer. So here we are going for an underfitting, and here we have to use this regulation for the overfitting. When we are going for the deep learning, what will happen here is my model is going to give the performance well on the test data. If it is yes, then it is a good model. If it is no, it is not. It perform the training data sets. It is an command. If it is yes, it is an overfitting, and if it is a no, it is come under the underfitting. The bias variance is important in deep learning with respect to the complexity of the neural networks. While learning models are able to reduce the bias by capturing complex patterns, they tend to run into a very high variance. This is trade-off must be managed very effectively. So in deep learning, so these are the have to maintain. In test datasets, it will be working well. Then it is a good model. If it is not working on the test dataset, it will be checking in the training dataset. If it is yes, yes means it is come under the overfitting. If it is no, it is come under the underfitting. So underfitting and overfittings, we have seen that. Underfitting means that model is too simple and does not cover all the real pattern in the data. Overfitting means that model learns not just the underlying patterns but also noises or random quicker in the training data. The model memorizes the training data. A good model finds the right spot. It is complex enough to capture the real patterns, but not small so complex it is and memorizes ones. So what is underfitting? So these are the content where we have to cover in underfitting. The model is too simple, very high regulation, Features are weakness or missing, not enough training and high bias. When you go for an bias inside the underfitting, underfittings mainly cover due to the high bias. High bias means the model makes a more strong assumptions, ignore the patterns, learns and overlay simple representations. Variance is low because the model gives simpler output even if the data is changed. This is the equation for the underfitting. Like underfittings is equal to high bias plus low bias, then it will be an underfitting. Overfitting, it will be cover this part. So what is this overfitting means? Model is too complex, too many features, very little data, no regularization, high variances. The overfitting happens when the model learns too much from the training data, including noises and outliers. It performs very well on the training data, but poorly on the test data. Overfitting happens, so these are the points we have to cover and we have to check during your overfitting. The variances errors that happens when the machine learning model learns too much from the data, including random noises. Overfitting is mainly causes by the high variances. So high variances means model react to the strongly or to the training data, learns noises as pattern, low bias because the model is extremely flexible. So what will happen if it is an overfitting means we have the low bias and high variances. We have that next in we are comparing that overfitting and underfitting in ML. So here the straight line trying to fit a curved data sets but cannot capture the data's pattern, leading to poor performance on the both training and testing. Overfittings that then sequence covers passing through all the data training points, falling to the generalizations and performs well on the training data but poorly on the test data. So approximate fittings curves that falls the data trend without complexities to capture the pure pattern in the data. So you can see that data which we are described in this slide. Okay. So this is also some curves which you can see that data is cover all the data here. That is an overfitting. This is a good fit. Okay. That is approximate fit. This is another fit. Right? Okay. How to address overfitting and underfittings? Techniques to reduce the underfittings: use more complex data, add more features, and performs a new, more complex model. Add new features and performs a feature engineering. Reduce regularization. Train for more epochs. Scale feature properly. So with the help of these techniques, I can reduce the overfitting. So how to reduce for the underfitting and overfittings with the help of this more complex, I mean, collect more training data, reduce model complexities, use regularization and L1 and L2, apply the dropout. So here we have to use the dropout for the neural networks. Use yearly stopping, clean noisy data. So these are the way to techniques the overfitting, and these are the way to reduce the underfitting. So this is a summary of two bias and variances and underfitting and overfitting. So bias is an error caused by overlayings of model and that ignores the important patterns. Variance is an error caused by highly complex model that learns noises in the training data. High bias, like it is we are calling as underfitting. High variances we are calling as overfitting. Like, so what is the underfitting is high bias plus low variances. Underfitting means low bias and high variances. So how it is caused? Inefficient model, complexity or missing features. Here two complexities or inefficient regulations. How to reduce the bias? So reducing the bias with the help of a more complex model, adding features, reducing the strong regulations. So reducing features with the help of an simplifying the model, adding the regulations, collecting the more data using the dropout and